So what I'm going to demonstrate, a little bit what's going to happen with the ocean in the future, right? And you know, we drive our cars, fly airplanes, and we use fossil fuels, right? We put gasoline in your scooter and in your car, and when you burn that gasoline, you produce carbon dioxide. So that carbon dioxide goes up into the atmosphere, right? Is carbon dioxide good? No? Why not?
It's actually good for the trees.
It's good for the trees. Why is it good for the trees?
Because the trees breathe it.
They use carbon dioxide, right? To produce sugars. What else do they need in carbon dioxide? What else do they need in carbon dioxide? How about sunlight? Sunlight?
I didn't know that came from.
Carbon dioxide? And water. Right? So use that to make organic material, like sugars, right? So this is an example, right? It's a photosynthesizing plant using sunlight, CO2 and water. And we have plenty of plants in the ocean, like we have some sargassum here, right? It's doing the same thing. It's using CO2, water, and sunlight to produce this organic material. Okay? When we drive our cars and we use fossil fuels, we burn those fossil fuels and produce CO2. That goes into the ocean, or it goes into the atmosphere, right? That's bad because the CO2 is a greenhouse gas. So if we're adding CO2 to the atmosphere, it gets warmer, okay? The greenhouse gases are important. That's what's keeping the planet at good temperatures to live here. But if we're adding more, it's getting warmer, and it may get too warm. So it's bad for us and for other plants. But part of the CO2 that goes into the atmosphere actually goes into the ocean. So what we're going to show now, we have a tank of CO2 here. So we're going to take that CO2 and we're going to bubble the seawater here and see how it's changing the pH. The pH is a measurement of the acidity or the acid-base balance of the water. What is it right now? 8.182, right? Okay. So now we're going to turn on our little CO2 tank here. Okay, you should see it starting to bubble. So we can stir this a little bit. What's happening to the pH? It's going up. Look carefully again. It's going down. Okay. So this is exactly what's going to happen when we burn these fossil fuels. We're putting CO2 in the atmosphere, and it goes into the ocean. We're changing the pH. So the pH is going down. Okay. So it's becoming increasingly acidic.
So the lower the number of 8, the higher the acidity.
Exactly. So it's kind of a complicated thing because the way we measure pH, we use a numerical formula to calculate it, so it inverts the numbers. So the more acidity, the lower the pH, essentially. So now we're kind of cheating because we're taking the CO2 from this tank and we're just bubbling it straight into the tank, right? And when we drive our cars, it goes into the atmosphere. So you may ask, how does that CO2 actually get into the water? And one analogy is if you take a can of Coke, right? If I shake this, and then I ask you to open it, will you do that?
Oh yeah?
What will happen if you do it? It's going to explode. It's going to spray all the soda all over the place, right? We don't want to do that. The reason that happens is because in this soda, there's CO2. It's a carbonated drink, right? So when you shake this, we're actually pushing the gas out of the solution. So we're building up the pressure. And we open it, that pressure is pushing the liquid out of the can. Okay? If we leave this for a while, for an hour or so, we can open it, no problem. And that's exactly the same thing that happens when we drive our cars, we burn fossil fuels, we put it into the atmosphere. We're building up the pressure of CO2. And that CO2 is getting pushed into the ocean. Okay? The acid-base level is very important in controlling biological and chemical processes. Okay? So if we're changing the acid-base level, we will change the way organisms and ecosystems function. Some organisms that may be especially vulnerable are, for example, coral. Does anyone know what type of coral this is? What is it? Great coral. Great, you know everything. Maybe you can be my assistant here. Ah, okay. Maybe if people want to look at that, pass it around to people if you want to have a look. So corals, they make their shells or their skeletons of calcium carbonate. So they take calcium, they take carbonate, they put it together to form calcium carbonate, right? Okay? If we acidify the ocean, I know a lot of you just showed up, so you may not be aware exactly what we did right here. But what I just did is that we have carbon dioxide here that we bubbled in this tank with seawater to show what happens to the chemistry. And that's exactly what happens when we drive our cars, we fly airplanes, we put CO2 in the atmosphere, it goes into the ocean. And what we saw was that the pH, which is a measurement of the acidity, was going down, which means that the acidity was going up. So what happens now when we burn fossil fuels is that we increase CO2 in the atmosphere, we increase CO2 in the water, and the pH goes down, and acidity goes up. All right? So when this happens, the carbonate ion, which is an important building block for coral, is decreasing. Okay? So the more acidity, the less carbonate. And less building material for corals. Okay? So if you have less building material, you will grow slower. You may also produce weaker structures, so you're more vulnerable to any physical stress. Okay? So corals is one example, but if you look, this is just some sand from one of the South Shore beaches. And if you look in here, this is essentially body parts. It's just fragments from different calcifying organisms in here. And there's also some pink stuff in there. Do you know what that is? No? Any guesses? You all know about the pink beaches, right?
Yeah.
Why are the beaches pink?
Shells.
It's shells, absolutely. It's an organism, it's called a foraminifera. Okay? Foraminifera. If you guys want to look closer, pass it around. They also produce shells of calcium carbonate, right? So they may also have a hard time if we're changing the chemistry of the ocean to produce their skeleton. Okay, so in that case, you know, what's going to happen to the pink beaches? We don't know.